Alright guys, we're going to continue our discussion about composite functions. Last time we talked about what is a composite function. It's where you are plugging one function into another. And then we learned how to do that with equations. And today our goal is going to be to work with composite functions, but doing it with tables and graphs. We're not going to, equations, I'm curious. Maybe I forgot, but we're pretty much focusing on tables and graphs. I don't know what we'll see. Maybe there is something we're going to do with equations today. Let's see. Aha, yes. Okay, we are going to work with equations a little bit more today. Okay, so we're going to finish up talking about equations, and then we'll get to tables and graphs with composite functions. So what makes example 1 here different than last time is that we're actually plugging numbers in this time to find the answers. So how do you evaluate composite functions? So we have the function p and we have the function q. They're asking me about a composite function here, p of q. But they want me to plug 3 into it. So so there's two ways you could do this. There's the hard way and then there's the easy way. Now I'm going to just tell you what the hard way is. I'm not going to write anything out. But I'm not going to use that method actually. I'm just going to show you the easier way. So the hard way would be to figure out what this is first, using what we learned last class. And after you get your answer, then plug 3 into it. That would work. It will give you the right answer. The problem is that if you do the first step wrong, you'll get the answer wrong, right? And then second of all, sometimes that first step is a lot of work. So there's actually a little bit of an easier way to do it. Here's how it works. Step 1, we're going to plug 3 into the q function. So plug 3 into q. That's our step 1. So let's do that. So q of 3 is 9. Okay? So now that I know what q of 3 equals, right? I know q of 3 equals 9. So now I'm going to plug what q of 3 equals into p. Okay? So q of 3 equals 9, right? So that means I'm going to plug 9 into p, because that's what q of 3 is, right? Q of 3 is 9, so p of q of 3 is the same thing as p of 9. So I'm basically just going to be plugging in 9 into the p function now. So p of q of 3 is the same thing as p of 9, which is 2 times 9 plus 1. And so the answer is 19. Okay? So step 1, plug 3 into q. Step 2, take your answer and plug that into p. And you're all done. All right, let's do another one here. So you just basically start from the inside out. So now I'm going to plug 3 into p. And I get 7. So now I'm going to take what p of 3 equals, which is 7, and I'm going to plug that into q. So p of q of 3 is the same thing as p of 7. I'm sorry, q of 7. So that would be 7 squared minus 7 plus 3. There you go. So that is how you can evaluate a composite function. In other words, that's how you can take a composite function and plug a number into it. All right, so why don't you guys go ahead and pause the video here and see if you guys can get the correct solutions to these problems. All right, so there's your answers. If you were to plug 1 into the m function, m of 1 would become 1. And when you plug 1 into the end function, you get 1/4. If you plug -2 into the end function, you get 1. And when you plug that into m, you get 1 as a final answer. So, you guys have it. Okay, now we're going to talk about evaluating composite functions as tables. Okay, so we're going to do this pretty similarly. It's just that we don't have to do as much calculation. You just have to know how to read the table. So, Q of 2. Let's find out what Q of 2 is first. So that means I'm going to look for x on my table, and I'm going to find what Q equals when x equals 2. So here's x equals 2. Here's Q. So when x equals 2, Q is 3. So I'm going to replace the Q of 2 with what Q of 2 equals. Q of 2 is 3. Now, I'm going to look for where x equals 3 and find out what p equals when x equals 3. So here's x equals 3, and I'm going to look for what p equals when x equals 3. And the final answer there is 2. So there you go. So once again, start with the inside. Once you figure out what the inside is, replace it with the actual number it equals, and then finish the problem by just evaluating like normal. All right, let's do another one here. So first I want to find Q of 0. What's Q of 0? Q of 0 is 5. Now I need to figure out what's P of 5. What's P of 5? It's 4. Final answer is 4. All right, next one. Let's see. Q of P of 3. So first of all, let's do P of 3. P of 3 is 2. Now I need to do Q of 2. Q of 2 is 3. All right, so that's the basic idea. Now on your homework, I think they're going to give you a table like this, and I don't think they're going to ask you the problems like this. They're just going to say complete this table. So what do they mean by that? They mean you're going to plug this x value into the composite function. So what's P of Q of 0? And then you're going to do 1. And then you're going to do 2. And so on. Now, don't just write this. You actually have to figure it out. Like we did Q of 0. We did P of Q of 0 earlier. What was it? Q of 0 was 5. And P of 5 was 4. So this is what you would put in the table as 4. P of Q of 1. I think that one was 5. And then P of Q of 2. 2. And so on. So they want you to do that. And so same thing here with this row. You're going to do Q of P of 0. Q of P of 1. Q of P of 2, etc. And put the actual answer in there. So I wrote it like this because it's easier to explain that way. But on the table, for your homework and also, I don't know, maybe even on the student practice, I want you guys to fill in the table. Let's see what you get. Okay? So there's that. Here's one for you. So I want you guys to complete this table. So once again, for this first one here, P of Q, right? So we want P of Q of -3. So find out what that is and put your answer here. And then you're going to do P of Q of 4. You always go with the x value at the top, right? That's what we're plugging in, is the x value. And then P of q of -5, etc. Okay? And then when you come down here to this one, it's reversed. It's q of p of -3, q of p of 4, etc. Okay? So go ahead and pause the video here and fill in your table and see what you guys get. I'll reveal the answers shortly. All right, and there's our solutions. Go ahead and study that if you feel you need to. And then we'll go ahead and move on to our next problem. Okay, so we're going to do the same thing now, but instead of working with a table, we're going to work with a graph. So let's do it. We have two functions up here. I think I will color code them just so it's easier to talk about. We have the g function. And then we have the f function. All right. So for number one, once again, we're going to start by finding out what the inside is first. So I'm going to figure out what's g of 0. Now, what that means is I'm going to look at the g graph, the green graph, and I'm going to find where x equals 0, and I'm going to find what y is. So I'm looking at the green graph, and I'm going to find where there's a point on the green graph where x equals 0, and that would be right here. At that point, x is 0, and y is -1. So g of 0 is the y value. So I'm going to replace g of 0 with the y value, which was -1. So g of 0 is -1. And now I'm going to find f of -1. Now for the f function, we're going to be looking at the red line now. And I want to find where does x equal -1. So let's look at my red line. I want to find a point on the red line where x is -1, and that would be right here. And the y value that goes with that is our answer, which is 2. So f of -1 is 2. All right, let's do another one here. Okay, so this time we're going to start off once again with the g. We're going to find g of -3. So in other words, I want to find where does x equal -3 on the g function. That would be right here. And I want to know what's the y value that goes with that. It's -2. So I'm going to replace this with the y value, which is -2. Now I want to find where does the red line, the f function, have an x value of -2, because that will be my answer. So let's look at our f graph, the red line, and find where x equals -2. That would be right up here. And the y value that goes with that is my answer. It's 4. So therefore the answer is 4. Okay. Let's go ahead and do another one. At this point, it might be good to pause the video and try these a little bit. You're still going to get a student practice afterwards, but these ones I explain a little bit more rather than just putting the answer up and calling it quits. So go ahead and give it a shot, see if you can figure some of these out. Let's go ahead and do number 3. Now for number 3, the first thing we want to find is we want to find f of 1. Now f is the red function, so I'm going to color this in red. So I want to find where does x equal 1 on the red line. That would be right here. And the y value that goes with that is what I'll replace it with. So the y value that goes with that is 2. So I'm going to replace f of 1 with 2. And now I'm going to figure out on the green line, the g function, where does x equal 2? And what's the y value that goes with that? And the answer is -3. Let's do one more here. Okay. All right, so first I'm going to start off with the inside function once again, which is the green one, g of -2. So I want to find where does x equal -2 on the g graph, and that would be right here. And the y value that goes with that is -1. So I can replace this with -1. Now here's something interesting. This time, the inside and the outside function are both g. So I'm going to stick with the green line now, and now I'm going to find where x equals -1, which is right here. And the y value that goes with that is 0. So the final answer for this one is 0. Okay? And so that's evaluating composite functions on graphs. A lot like the table, it's just that you have to read the information differently on a graph than you do on a table, but the process is still the same. Start with the inside and work your way out. All right, so here are two problems for you guys. I've got two graphs. I've got the function u of x on the left and the function v of x on the right. And then numbers 1 and 2 down there at the bottom, I'm asking you to evaluate those composite functions. So go ahead and pause the video here, and when you unpause it, you'll see the solutions. All right, so number 1, the answer is 2, and number 2, the answer is 0, so let's see why. U of -1 is 1. It's right there. So we replace u of -1 with 1, and that leaves us with v of 1, which is 2. That would be this point right here. Next we have v of 5. V of 5 on the v graph is down here. That would be at -2 for the y value. And now we need to do u of -2, which would be right there, and the y value for that is 0. Okay. I think that does it. So it's another lesson down, and we'll call it quits until the next one.